Chị mất thêm một cái mình kinh doanh và kinh doanh. Không đi không? Cái chị nó chắc là do ai ngoài không? Thì đỡ mà. Sau này
Phổi đã bảo hôm nay lỗi thật. Cả cái phòng này đều bị hết rồi. Đấy, rồi ok ok.
Hello everyone.
Hi.
How do you feel today?
Wait.
Wet? Okay. In case you don't feel wet today, so I'm going to introduce you to Omniverse. A
Okay.
brief introduction to Omniverse. Have you ever heard of this before, or have you ever searched on this?
I remember this part. Yeah, it's already done.
Done this before. I also remember that there's some terms and some explanation that I do want to investigate time in that. That's why I made this topic one more time. Okay, I hope that you find this like a different way, maybe just the core concept, but a way that may interact you in some manner. Okay, let's get started. Okay, universe. First thing first is content. It's the first origin, structures, terms, and the last one, which is the most interesting one, I think, is controversial and showing. If something is fact for the origin, I do believe that there are many theories in how the universe is constructed, but my opinion is always up to the first origin is Big Bang. You always know that, right? Big Bang theory. Also the name. The name came of band, right? And do you remember anything about this? Because you said, that's why I presented for this one. So I wonder, have you ever remembered anything about this? Come on, let's raise your hand. I want to see.
This is like a big explosion out there. Of the universe. So that several planets are formed. I think.
Several planets.
Yeah.
To be specific. You guys, you were the person that made this topic, so you should have something in mind, right?
Sure, I don't remember the first step of the universe just about a solid. Solid. Point. And it grew the hydrogen.
Hydrogen.
I don't remember exactly.
Okay.
Yeah. But the equation just happened in the very short moment.
Short moment. Do you know how short it? Do you remember how short it? It's extremely short, and let me show you. The first one I like to tell you is at a very accelerated time called inflationary epoch. And what's this? This is the moment, the first moment that there's a point. You consider this universe as a point. And this one called inflationary epoch and expound the universe. Okay? For the next one, the universe get like after amount of time about 10 to the power of minus 32 seconds. So you get a number on the minus, write it out on the board. So this is about the time. 10 to the power of minus 32 seconds. So this is the time that the universe gets expanded. But before that, it gets cooled and continue expand this moment. What next? And after this moment, the particles and atoms start to form. We get enclosed as several. It's influenced by the gravity forces, and also by the four fundamental forces also. The gravity makes the dark matter. Here comes the dark matter. You guys know anything about the dark matter? Are you real ones? Do you remember all that? Tell me something about it. Come on, want to hear something from you? Because you got it. The dark matter. Yeah, no, it's not energy. It's not dark energy. It's the matter. Yeah. I think I'm going to explain this theory to you later. I do have a terms we call dark matter and two other things. So just bear it in mind, dark matter. I'm going to explain it later what's that. Okay? And the gravity makes the dark matter gather together. Okay, just imagine that the universe has a lot after the formation of the universe from this point. And it's get cold, some particles are there, and atoms, of course, and the dark matter here. The particles, this dark matter is 85% of the whole universe. It's still true up to now. Here comes the hydrogen and helium, the very fast atoms in the universe. And after that, it's not just several planets, the whole galaxies. I mean, many galaxies are going to be formed, and stars, and so on, everything that we've seen today, and how the Big Bang goes. Okay. The next thing is about the structure of the universe. This one I think is the most intricate. Like you can see, it has a structure from the universe, Milky Way, billions of galaxies. Do you know Milky Way?
Yeah.
This is not the middle of the ground, okay? It's not the ground. It's not as Milky or kind of that. Milky Way. Okay, you see, I organize it in a way of scale, in the scale level. So Milky Way is actually a galaxy. Okay, it's our galaxy. Our universe has Milky Way and Milky Way. Okay, I'm going to start from the root first. So here comes Mr. Silver. It's me right here, okay? In our planet, I've got billions of people like me, and we have actually 8 billions of people, right? And we all live on Earth. The Earth, along with other planets, with the Sun and other billion, not billions, okay? The solar system has several planets. We got a billion solar systems, right? And after a billion solar system, we got a Milky Way, in our Milky Way. Okay. A Milky Way called a galaxy. Billions of galaxies make the universe. That's how the structure of the universe. I think it's clear. Nothing to discuss about. Okay. And here comes the terms. The thing that I want to explain to you. First thing is for the dark matter. I'm going to explain it deeply in this way. The dark matter. Why did it call it dark? Can you get it? Why did it call dark? Can you get it? Something dark. What do you see when you see? How do you call something dark? The dark hole. No. The hole. You mentioned maybe the black hole. It's not the dark hole.
I think every single thing in the universe is shining because of the light.
Right.
But dark matter may be exceptional.
Yeah. Kind of a black hole, you think?
A black hole.
Yeah.
Black hole is the gatherer of dark matter.
The dark matter is called dark because there's no radiation detected in this kind of matter. And the only way of recognizing this kind of matter in the universe is because our universe don't have the dark matter. It may not behave the way it's just now. It will not constantly moving like this. Okay? Our whole universe may like shaking or maybe move around. It cannot be constantly like this. So the scientists, they cannot see, all the astronomical instruments in this world today cannot see any visual evidence of dark matter. And of course, it's emit no light. It appears to interact with no radiation. For example, with light and maybe kind of a visible ray, kind of that. It cannot interact. Actually, we cannot detect it interact at all. So it's undetectable kind of matter. So we call it dark matter. And I say to you that the only way to detect, to predict actually, because we have no evidence, right? So scientists believe that this kind of a matter in the universe that take the mass of the universe, like fill up some mass into our universe so that it has big enough, it's strong enough to not shaking, so it stays constantly like this. So it consists of 80%, 85% of all the matter in the universe. And the same thing with black holes. You say that black holes, right? One more time. I want to hear something about you. Little girl, stay silent. Have you ever heard about this before?
I think that black holes and maybe no light and it is negative.
Negative? It's
I
negative.
think that
Yeah, you can just guess it.
Yeah.
So, talking about the black holes, I want to mention about the space-time. The space-time. What is space? Here is space. What is time? And the time is relative, according to Albert Einstein. So, time and space are relative. And when we mention the black holes, we're talking about space-time. Every light is actually something like every light. There's no light escape from this, no other matter escape from this black hole. It's all have a gravity. It's pull everything into the black hole, so they cannot escape, even the light. Okay, so the black holes in this way can, the origin, how to form the black holes is based on the theory of that something big enough. I mean, the mass is big enough so that it's pulled, it's disappeared from a star at the end of its life cycle. It's gonna, the star is very heavy, right? So when it appears to like disappear, it goes somewhere and in a space, and they call it space-time. It disappeared and then it's formed a black hole because it's too heavy in a limited space. Okay, it's formed black holes, and it's still evolved. It's not just that. Okay, the black hole, a many black holes. So when a black hole formed, after that it still evolved, right? It maybe go with another black hole. Surrounding it grow by absorbing all the other matters, surrounding matters, and go with another black hole to form a bigger black hole. Like that. In our Milky Way, there's also a big black hole in the center of Milky Way. It's called Sagittarius A. This is the kind of black hole, Sagittarius A. And scientists believe that every galaxy has at least one black hole, the biggest black hole like that. And the last one is the thing, the multiverse. Heard about this before? The multiverse?
Multiverse? Does it really, is there anything related to the parallel universe?
It's exactly the same. Exactly the same.
means many and
Yeah, many universe.
It's a theory, right?
It's a theory only. No one can prove it. But I place it here because there are many theories about that. Then, have something about that before? There is a theory about universe like when you are here, like me, I'm presenting to you guys here, right? Yes, I'm a person in some other universe, just like me. And there are also people like you understand it. It's not us. We are in this space, but they are the same vision of like another universe, do the same thing, same action to you and me. Like you do the same thing, you touch your nose, the girl in there touch your nose too. Me speaking, another guy speaking the same to me, the same appearance. So, how do you think about that?
I think it's quite insane first.
Insane facts?
Yeah, but later on, I think it's quite rational because sometimes maybe some mystery related to the human that is normally we can't explain, but if applied to this theory, it can explain somehow. I think, for example, the subconscious mind or some kind of materials in the space, for example.
Yeah. But about this multiverse, I do think that it's insane fast. But after that, actually by reading the theory, the author of the book they read, he claimed that it's based on one questions. Okay, for this multiverse terms, I'm gonna open the first question. It's quite controversial. Okay, that is controversial. The first question is also is all about the questions. The first question is our universe still expanding? How do you think? Still.
It's always.
It's always. How can you be sure of that?
Because I have watched a video related to this one, and people refer to the term that the end of the Earth, and it says it's nonsense because our galaxy will never end. There will no limitation for the galaxy, especially the universe. It will always
Still expanding.
moving and evolve.
But you know what? All the scientists in the world can prove this one. So what you watch, maybe it's just a theory, like
Yeah.
some other thought. They believe that it's still expanding. But how? The theory based on the multi-dimensional space. So we are living in the four-dimensional, it says three-dimensional space, right? But there is a theory about multi-dimensional, at least more than 10-dimensional space. So our universe is expanding that way. At first, there's a theory expanding. It's just a theory. So the author that I read from that, he claims that our universe is still expanding. And because of that, because it's still expanding. So actually there's no limitation for our universe. If you consider it as a universe, right? Our universe right here, expanding. And by the term expanding here, I mean, it's not just one universe. Maybe outside of this universe, outside of this one. Can you guess what that? This is our universe, right? And outside of this. Outside of this. Can you guess what that? What's outside of the universe? You cannot predict that. You cannot see that, right? So expanding means maybe our universe here, another universe here, okay? Because this universe is never gonna stop expanding. It expands forever. And there is a theory about number in an unlimited range. Unlimited range. The chance, like for example, I'm gonna generate numbers, a number, like 1, 2, 3, 6, 5, 4, because it's unlimited, okay, like forever. So the chance of getting this one again is possible. It could be very far, like it's rare, but it could be. Maybe the range could be 10 billion or 100 billion. Because it's never stopped growing, just like our universe. It's never stopped growing. Then the chance of meeting another universe is never stopped growing, right? So inside it is multi-universe. Universe 1, universe 2, 3. And because of it, it's never stopped expanding and you still have the chance, it's unlimited, right? So sometimes in here, and maybe this one parallel to this one. Because it's not limited, it's unlimited. You can say that, yeah, it is limited. You may not find. Because it's limited, you can say it's clearly, it's easy. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In those 10 numbers, I cannot find another number like this one. But what if you cannot see the unlimited range? You cannot tell if it exists or not. Maybe it exists, you don't know. That's the point. So that might happen. I don't know. Space-time, you might see another universe, parallel to us. So I do believe that multi-universe have existed. To come back to the term, this one is just a theory, okay? It's just a theory. It's nothing is proven. But I like the theory. You know why? Because I'm wondering if the person just like me in another universe, how is he doing? Maybe he has another life. And this kind of theories has actually motivates a lot, inspired a lot of movies. Now you ever watch the Death Birthday Party? Death Birthday Party. Watch it?
I've just watched the first version.
What version? So
They got 3, right?
I don't remember. I watched last year, and it's inspired by this story.
Yeah.
Multi-universe, like about a boy travel to his birthday party, right? He can again wake up, and each time I wake up, each time he died, and he come back exactly the same. I mean, this is not the universe. It's not the same one, because he died in this universe, and he needs to get out into another universe. Because of his machine, own built machine. It's kind of a time machine. Okay? So this is one movie. I do it more or less one movie. Okay. And the second, why do scientists know things billion years ago? Why? You already heard that yet? NASA has proven like evidence out there. They proved it. They saw it some way. They use a telescope to see something. But how? Have you tried to answer it? Wonder it? Yeah, I just remember it. Yeah, they are talented, and does that make sense, right? Could it be possible if they can predict the exact time? Like our universe has 13 billion years ago formed. 13 billion years of light. It's not normally years of light. How can they know? It's too far away. How can they know? Alright, okay. Here comes a thing. First, let me tell you one thing. All the stars you're watching now is not actually the current time. It's the stars from billion years of light ago. And it reached your eyes today after billion years of light. And what you observe is actually years and years ago, like it's past. It's not current time. So even if you have a kind of a spaceship and you in a second you can come to that star, no, it's not going to stay that way. It disappears. Maybe. But it's one thing I can be sure, this is not the star in there right now. Maybe it's collapsed. We don't know. Because the light from that star comes to us takes at least like billion years of light. We don't know, right? So based on that, imagine it is the Big Bang. It's a spark, and until now, the light and everything in between still here is our people in here. People on Earth. It's 13.7 billion years of light year. So because this still emits, the light still emits, and we still can take and observe the light. Because what we see is actually 13.7 billion years ago. So all the things they claim is actually what they observed from this Big Bang. It's real. It's just not now. It's so far away, and they can still observe that. And it's actually made it that we still can see things from 48.7 million years light. Yeah. So imagine that you can still live until this moment. Okay, you can still see this one because the light lasts forever. Actually, it's not going to end. So like I say, it's not going to end, and that's why people still see it because it takes time. Because you already know that from physics, everything is seen because the light from the object comes to our eyes. Right? So that's the point. And the last question. Why do people on space stay younger? Why? On space. Stay younger.
Can you explain more about this question?
The space. I mean this like outer space, okay? The outer space. Someone, if we stay here and we have another person, our friend, for example, come to space, and when they come back, they look younger. In this planet, 20 years past, but with them, just 2 or 3 years past.
I've heard of this before, but I can't understand.
Yeah, so there is a story about a tree. A train, okay? The first train stayed in the planet, and the second train traveled in a ship, like a spaceship, with a speed of nearly the light, nearly equal to the light. And there is a theory about time, because time is relative. So if you move faster, time goes slower. If you move faster, and time goes slower. So because the fast train stay here and move very slow, basically essentially the same with the time. Okay? The same train. In the space time, in the spaceship, with the travel with the speed of light. Of course, merely because of the speed of light, not the speed of light. I will explain later. Then, because he moves so fast, and there is a theory about the moving. We move faster and time moves slower, and that's why this guy is younger. And the number that actually decays in here, the second train only feel like 2 or 3 years past, and that's it. What's the point? Okay, that's what just everything is a theory. No one can do that. You know why? Because to find something at the speed of light is impossible. Do you think it's possible? Something in this world has the speed of light. No matter you heard of a machine, a plane that can have a speed of sound, right? The speed of sound. But until now, there's no kind of machine that has the speed of light. Do you know why? I don't wonder. Because the velocity of everything, okay, is based on 2 things. The first thing is the mass. Everything has a mass. So, yeah, look. And it's affected by the gravity. Our planet has gravity, and that's why it's called mass. Okay? It has a mass. So, for example, we have a machine like this one. Can travel, but it's always be affected by the mass. But how the light? It has no mass. It has no affection from the gravity. So until the time can develop the machine, even to reach the speed of light is hard, it still depends a lot on the mass of the machine. I don't think it's easy. I don't think it's easy. That's the point. And scientists claim that it's impossible. Maybe it's possible in the future. I don't know. But they are so sure that there's nothing in the world can have the speed of light. Okay. That's about controversial. And also the last thing I want, the last slide of our presentation. No, thank you. Sorry. The same way, it's like the last meeting. Okay, the question is at the end. Okay, I'm going to turn off the camera.